Good morning and good afternoon, and this is Monica Paolini from Senza Fili, and today we're talking about MulteFire. It's a new technology that uses LTE as the air interface and provides supports applications for many things, and among them are services for the enterprise across different verticals. And today I'm talking to Prithu Prakash, who is the VP of Business Development at Redline. And we'll hear from him what is that they're working on, who is it they're working with, and in which vertical. Prithu, thanks for being with us today.
Thank you. It's a pleasure to be here.
So, Prithu, can you tell us what you're doing at Redline and what is Redline doing?
Sure. So Redline is a company that's been around for 20 years. We're headquartered out of Canada, near Toronto. And we support the oil and gas, military, government, mining, public safety, utility industries. We've deployed in across 55 different countries. We design, build, manufacture, deploy, and support our own equipment.
So you know very well all those verticals. And so how did you get into MulteFire?
So MulteFire offers a number of capabilities for us. And we're very interested in how it progresses, how the IEEE and how 3GPP support the MulteFire Alliance. But one of the main critical questions that it addresses for us is the ability to operate an unlicensed spectrum.
And why is that important?
Well, today, 802.11 operates in unlicensed spectrums globally. There are pockets of spectrums that are stranded globally. And having a protocol like LTE operate in those spectrums, in those bands, is extremely advantageous. We would have the security, the uplink, the downlink, the RF mitigation across these unlicensed spectrums using a superior protocol.
Absolutely, and then the enterprise can deploy that on their own without having the need to work with an operator, right? So they can run their applications locally.
That is correct. Today, licenses are bought by most telcos. They support the consumer market, and some of our customers use commercial bands today, but they would rather use their own and deploy a private dedicated, secure communication network, so they have full control of their own operations.
Yeah, and when I talk to the enterprise, the issue of control, it's really crucial. But at the same time, it's different depending on the verticals. So what control means in different environments is different, and what type of requirements they are different. Can you tell us a little bit what verticals are the ones that that benefit the most from MulteFire?
So MulteFire, if we break it down into three main components, we could address which verticals would need certain aspects than others. So looking at it from a business perspective, if we look at it from price, spectrum, deployment, ROI, risk of obsolescence perspective, then the cost would be reduced. There's no annual fee you would pay a telco. The spectrum perspective, they will be able to deploy, whereas they couldn't before without violating the spectrum regulator laws and rules. From a deployment perspective, MulteFire would be easier to deploy than a telco, whereas telcos have defined cells. Here with a microcell, the protocol, the technology would be able to coexist with lower interference. From an ROI perspective, well, if you're paying $100, $80 to $100 per device, you will no longer pay that. So that ROI would be reflected back based upon the return period of the program. From a technology perspective, there's capacity, coverage, latency, mobility, interoperability, security, and the ability to evolve business and operational needs based upon a base technology being MulteFire. So that takes us to what would be the operational benefits. We talked a little bit earlier about the ease of use, the support use cases. and we can go into that a little bit later, accuracy, and speed of processes from an operational perspective. Now, looking at MulteFire as a base technology that can address all of these three pillars is a very positive step forward.
Yeah, so can you give us some examples of how that translates in practice? You know, what kind of applications, what kind of verticals?
Yeah, so if you're looking to have basic safety for individuals in a location, then MulteFire, having no spectrum, the ability to apply applications across a MulteFire protocol back to a core for a command and control, a C2 activity is important. That's from an individual safety perspective, knowing where all of the humans are within a given area. The operational piece, having equipment communicate back over a MulteFire protocol back to control. And then the third one is machine to machine, the ability to have various sensors to ensure safety levels are maintained and nothing goes haywire in any way, and there's no chance of a chain reaction of devastating events at any location. So with all of these three different types of capabilities that our customers are looking for, with MulteFire, you should be able to and would be able to define a priority to each one of those. And this is something that you can't do with a commercial network. So the difference between what a telco, what a commercial network would offer, it would be one colloquial capability for everybody as mass market. What MulteFire would hopefully give us would be the ability to fine tune the QoS, manage the latency, manage the uplink and the downlink for each of the three different use case types that I just mentioned, to not only increase security at our customers' locations, but also to increase operational capabilities and enable them to yield more product out of the mines that they are today.
So in this case, is there any barrier to entry? Is there anything that an enterprise that wants to deploy MulteFire should be paying attention to?
Of course, there's always barriers to entry. Otherwise, we won't be having this conversation. So the barrier of entry is training. How easy is it to deploy this? How easy is it to manage this? How easy is it to complement existing infrastructure? What kind of operational benefits would this technology be used for? So all of these are not showstoppers. They are conversations that are needed with a customer and to ensure that this technology is well positioned for its needs.
Yes. So can you give us you mentioned mining before, keeping track of assets and people. What kind of applications like in the mining industry you see?
So I mentioned three generically across our verticals. Our verticals being oil and gas, military, government, public safety, utilities, mining. And those three types were the safety of individuals. So if there was man down, the location of an individual, if there was no movement from an individual, from a mobile device, another individual which would be close to the area, and that close to the area could be 10, 20, 30 kilometers away, would be able to go and help. So safety applications based upon man down, based upon man injured. The second one was operational of machinery, where a piece of heavy equipment is in need of service and it hasn't been serviced and it's going to break down. So if a machine is broken down in a field, it could take hours to days to fix. How can we reduce the breakdown time frequencies? How can we increase operational efficiencies? And the third one is IoT. Are we able to put a sensor in the field, leave it there for 6 to 12 months, And is it able to communicate back to control with minimal management, minimal maintenance, minimal support, and keep the accuracy that's needed. Now, all of these types of applications would help our customers in general to increase their operational processes and reduce the cost of business generically.
Yeah. So now, whenever you talk about IoT and enterprise-specific applications, there is a question of are the devices available? Is that a concern?
Oh, always. I would love all of the devices to be available today. Today we are moving from 1.0 MulteFire to 2.0 to be available at the end of the year, and there are a number of trials going on. The MulteFire elements would be a core, would be a base station, and the devices at the end. You need all three to make the solution work. And the more customers we have that are trialing these devices, from a core to a base station to the UEs, the user equipment at the end, the better, the CPEs. We have a number of customers who are supportive and waiting for these devices to be available. And with the feedback that they give us, we will be able to better not only the standard, but the requirements as well. You asked what are the barriers to entry for enterprises and moving forward? What is the adoption? Well, lowering the spectrum barrier is good. Offering greater capabilities with MulteFire using LTE protocol as a base is also good. But that's not the end of the game. That's only a part of the equation. Making sure that the product and the platform is capable as a communications channel for our customers is also important, and how they're deployed. Offering best practices of how they're deployed will also be equally important. The aim is to make MulteFire as simple as Wi-Fi. But Wi-Fi is simple, but it's not that simple. LTE is extremely complicated. It takes telcos years to fine-tune a network. We need to make sure that all of those SON capabilities are inherent before we deploy with our customers. Deploying a technology that is quirky will not be a good move for anybody to start deploying.
Now, can you tell us a little bit about the bands where MulteFire will work?
So the bands that are available for MulteFire today are 400, 800, 900 bands. There's 1.9 trials happening in Japan right now, as well as a 2.4, 3.5, and 5 gig bands. Some of these are regional, others are global. The 3.5 is global, and the 5 is global. Based upon what unlicensed bands are available in various countries, those are the bands that obviously we would build products in. The distinction there is what would be the channel bandwidth that we could communicate within, the channel width within narrowband and broadband for a particular customer and application type. For the narrowband, it would be the sensors on the equipment. For the broadband, for the wider bands, it would be for video and communications through cell phones and other devices.
Now, you mentioned 3.5. Will it work in the US as well?
Yes.
How is that going to work within the CBRS framework?
So we're working with CBRS Alliance. We're members of the CBRS Alliance today. That's moving along very, very well. And the MulteFire and the CBRS directives are capabilities that we want to try to introduce into our product roadmap and for our customers and going forward. We see them as complementary.
Now, what about Wi-Fi? You said that you want to MulteFire to be as simple as Wi-Fi, but if you go to an enterprise, they could deploy Wi-Fi, or they might already have Wi-Fi and then MulteFire. How should they make that choice?
If they have Wi-Fi and MulteFire?
Yeah.
Well, the way Wi-Fi is deployed today is on an ad hoc basis. They're not really integrated together. The only place they connect together is usually at the application. The aim is to have MulteFire coexist with Wi-Fi. The difference between the two is how the RF spectrum is managed. With Wi-Fi, it's communicate, wait for an open channel, and then the communication is made. With MulteFire, it's using a scheduler from LTE, listen before talk, to harmonize the RF activity. The aim is that they will coexist together. The studies that were done earlier show an increased bandwidth throughput when a scheduler is used.
Yeah. So now another thing is that so clearly Wi-Fi and MulteFire can coexist. There's a lot of spectrum there. Now, one thing that you mentioned before, it's the safety, and there's going to be interest from military users. Can you comment about what is the security with MulteFire?
Well, we're using the LTE protocol as itself, and the security elements within LTE. As IoT increases and the risk of cyber attack also increase through cellular technologies as well, the risk factors, the risk vectors also increase as well. Mitigating that risk and the way MulteFire will address those is also equally important.
Absolutely. Now, the other thing that sort of following the question about Wi-Fi is you said, you need to make LTE easier, because right now when you have a national network, clearly it's a complex thing. How can you make LTE easier? What's the path there?
So today, when we connect to a network, we have user profiles, username, password, and off you go and you connect. With a mine where they would want to move base stations around as the face front or the mine front changes, deployment, RF spectrum analysis of deployments, all these factors. It's not just all these factors come into play. With Wi-Fi, we tie a router to a roof or put it in a corner of a room, and we hope for the best. When a telco deploys an LTE system, they do RF analysis way in advance of deployment. They look at locations, the heights, the azimuth, the fading, the street level coverage. The same would be needed for the mines, for our customers as well, to ensure that they have as much coverage as possible. The services involved in supporting RF analysis before deployment are equally important as deployment of the APs themselves. Now, deploying it is simple as putting an AP like IEEE AP up. Would it get as simple as that? I would like to think so, but there needs to be. I'm drawing two sides of the spectrum, from a telco and from an enterprise AP. There needs to be something in the middle. There will be a level of RF analysis required for a tunnel, for a mine, above ground and below ground, but not as much as what a telco does today. Now, deploying private, dedicated, secure networks is very, very different than deploying a telco network. Here we have a number of users that we know would be connected. It's not sporadic, as in we don't know how many users would be there at a particular time. In this case, we would know exactly what users would be there. In addition to that, we would also know exactly what kind of applications would be used on a MulteFire type of net, on a private MulteFire type of network. So we would be able to define the policies and the profiles to ensure the latencies are well calculated before the system goes live. And with these metrics in place, the pre-engineering work done beforehand will ensure that the network is already pre-optimized for the user, whereas for a telco, they're usually not. A telco usually deploys a network based upon best effort, and then they would tweak based upon traffic flow. Here, with a private, dedicated, secure network using a MulteFire type of protocol, we would be able to define what those are before time.
So do you expect the enterprise to do it, like for instance, a mining company, to install the network on their own, or who would they hire to do that?
Well, obviously they'll hire us to do that, but the aim would be that they could start with an understanding of what the maximum deployment would be, and then they would slowly build up to what their maximum deployment would be based upon their own efforts. But an RF grid, I think, would be prudent to move forward. What that means is that if they say we have 100 square miles of coverage that's required, then we would deploy that. And then they would execute on that based upon whatever their phases are of deployment as the mine evolves over the operational period of that mine.
Yeah. So you'd help them deploy it, but you don't expect, because that's not the core competence. It's one thing to put an access point here and there, but then to have a network that supports. It's not so much for the technologies, for the type of services that you support, that you need to have the perfect coverage if you need to have an application that requires that. So,
well, you can have you can have the perfect capability, the perfect technology, but if it's deployed badly, then it's only going to be as good as the deployment.
Exactly.
So I would say the initial step would be, yes, use the experts to do the understanding, the grid work, the RF planning, the deployment metrics. So they would have an understanding of what they would expect once they've deployed. But in order to do the installation, of course they can do that themselves. That's the whole aim. That's the whole value of owning, running, and deploying your own networks, which are the metrics and the merits that MulteFire brings moving forward.
Absolutely. So I guess it's the planning that is crucial, because, as I say, if you don't plan the network well, it doesn't really matter what the technology does. It's
exactly.
Now let's talk a little bit about the timeline and the roadmap ahead of us. What do you see there? When is it going to be commercial?
So we're waiting for 2.0. MulteFire 2.0. We're waiting for what 3G PP are going to do. We're waiting for the user devices to be available. We're looking at building a CPE, a base station ourselves. We're also looking at IoT in terms of process industries, manufacturing, and SCADA control. We're looking at industrial in terms of utility, power generation, power distribution, oil and gas, mining, and SCADA management. And we're looking at mission critical in terms of hospital, military, border security, public safety, anything that requires rapid deployment, like events, as well as our core industries as well.
So another question for you is, what do you think that the most important use cases are, especially with reference to the 3GPP definition of use cases?
Yeah, so the 3GPP release 16 standards draft document has identified 9 different types of use cases, and they range from rail-bound mass transport, building automation, factories of the future, Industry 4.0, smart living with healthcare and all of the IoT devices associated to that, smart city, electricity distribution, centralized power generation, events, and smart agriculture. Now, with all of those different types of use cases, it's important to look at MulteFire as a platform opposed to just a connectivity piece. Now, if we look at it from a platform perspective, then terms like personal grade, telecom grade, enterprise grade, public safety grade, industrial grade, including oil, gas, and mining, and military grade come into play. And with a matrix like that, we're able to identify the types of communication platforms that are geared for mass market and the types of communications that are geared for private market. And that takes us to private dedicated technologies like MulteFire. And the companies and the industries that require a private, dedicated, secure network then can start working on the core capabilities, being business, technology, and operational benefit for their individual needs.
Well, that looks like you have a lot of things, a lot of work to do in the next in the immediate future, in the short-term future. But it's all very exciting. So, Prithu, thanks for being with us and sharing your thoughts with us today.
Thank you. It's been a pleasure.
Thanks.